Bowling speed calculation, and that too using physics. How? Of course, what's shocking in it? Everything in the nature is governed by physics. So what's shocking in it? Yeah, that is also a point. But please tell how you are going to calculate it. Of course, we are going to discuss that only. Hello everyone, this is Aditya, and today we are going to discuss the bowling speed calculation using physics. It's really interesting to discuss upon it because cricket is a very famous game, so that is why we are going to discuss it, right? And of course, while making all the calculations, we are just going to assume all the ideal cases. We are not going to look into the real cases because then it will become very much complex, right? But before that, please do like, share, subscribe my channel, and please support this video. Now let's start with the video. So let me show you a clip so that you can understand the concept better. So I hope so that you must have watched the clip, and of course I did not use in national or international level players video because then I would have got copyright. So that is why I used my clip only. Okay. So now let's see the physics behind it. Okay. So notice that I was taking the run up. Okay. Since it was spin bowling, so that is why the run up was very small. That is the rules of cricket. We are not going to talk about that much. So maybe I was walking or taking the run up with a velocity, suppose v, right? Okay. Now this was the crease, suppose, and I bowled from here, right? I am neglecting all the footwork and everything. Just I am going to consider this v velocity, and while throwing the ball, maybe I threw it at an angle theta, right? So this was suppose the line, and I threw it at an angle theta, right? Okay. Now notice that this was the original velocity which I was carrying, right? This velocity will be transferred to this ball, right? Of course. Now notice that suppose after throwing it, it had got a velocity. Suppose this is v naught. It got a velocity v, right? So what is this velocity? This will be equal to v cos theta, right? And this will be v sine theta, correct? Okay, fine. So what is the horizontal velocity? Horizontal velocity, it is equal to v naught plus v cos theta, right? Final velocity. And what is the vertical velocity? Vertical velocity, it is equal to v sine theta, right? Okay. But now the question is, how do we find the velocity v, right? Now notice that this was my hand and I rotated it and I threw the ball tangentially, right? Like this, okay? And this was the angle theta, right? Okay. So notice that this velocity must be equal to r omega, correct? Right? It is the angular speed of my hand, and r I can write it as L, where L is the length of my arm, right? So this is how we are calculating the velocity v, right? So basically you can also write this expression as, suppose this is vh and this is v. So vh is basically equal to v naught plus L omega sine L omega cos theta, and v vertical is equal to v that is L omega sine theta, right? Okay, like this you can calculate. Okay. So I'm neglecting the air resistance and the ground friction when the ball falls on the ground, and I'm neglecting the rotatory speed of the ball since it's spinning ball, and even in fast ball also the ball spins a bit, which sometimes decreases the speed of ball and sometimes it increases the speed of ball. So that is why I'm neglecting that case. But if you want, you can calculate it. But since we are neglecting friction, you can neglect the speed due to spinning also, right? When the ball hits the ground, right? So this is how you can calculate the speed of the ball, right? You can calculate the v naught, right? You can calculate your speed. You can calculate the length of your arm, right? Okay. and you can calculate the speed, the omega which you are giving to the ball, right? Okay, and you can find the theta, so that you can find cos theta, and of course then you can find sin theta also. So this is how the ball goes when you suppose this is the pitch. So the bowler throws from here, the ball goes like this, then towards the batsman, right? Okay, this is how the ball goes. So it depends, this is angle theta, so this is equal to v cos theta plus v naught, and this is v sin theta, right? This is the case. So when the ball is thrown at 0 degree from this line, that is when theta is equal to 0 degree. So for theta is equal to 0, there is no component of ball which is going downwards, then whole velocity is directed towards the batsman. So that is why in that case, the velocity towards the batsman, that is Vh, will be equal to V plus V naught. And this is the maximum velocity that a bowler can throw towards a batsman. Why? Because there is no other angle which can give greater velocity than this value, right? Now notice that this v cos theta plus v naught, that is the horizontal component of the velocity, will remain constant. Why? Because there is no resistive force or supportive force acting on this component of velocity. Why? Because we neglected air resistance and friction. But since gravitation force is there, so this velocity, this vertical velocity, will keep on varying, right? Okay. So the batsman will see that the ball is coming with this velocity, right? So this is a very basic idea that how we calculate the bowling speed using physics, right? Of course, there's a device which we can use to measure the speed of the ball. I can't recall its name right now, but using that, it is very simple to calculate, right? But if we look from the perspective of physics, this is what is happening, and it is very superficial. I'm not going into depths. It is very much superficial. Of course, there's lots and lots of things to be considered in this, which I neglected. It is just very basic physics which I told, right? So I hope so that you understood this video. If you did, then please do like, share, subscribe my channel, and please support this video. Bye bye, take care.